What's up guys, welcome back to my channel, and today we will be solving this Catriona Aggvent math problem right here. So this was taken from the year 2015 and today we will be solving this problem together. And here we can see a large square and there's another square inside of it, and according to the details it says that all of those four corners touch the larger square. And this right triangle is created through this process with the area of 24 units, and we're supposed to find the area of this circle which touches all of these three sides of this right angle triangle right here. So you can pause the video for a while and think about it, because I'm going to solve it in 5, 4, 3, 2, 1. Okay guys, so first of all we have the area as 100. So I can name the side lengths of this blue square as 10. Okay guys, so after naming all the four sides as 10 units, now what I can do is I can take this purple right triangle right here into a different section, so we can solve that part only just separately. Okay guys, so as you can see, I slightly took out the right triangle from the figure. Like, I didn't take it out completely, I just wanted to show you guys something. So here we can see the hypotenuse as 10 units, so which means the sum of the lengths of the other two legs should be equal to 10 squared, which is 100. So now we have to think of a pair of squares which adds up to 100. So if you're familiar with this thing called Pythagorean triads, you should know that there are certain trios of lengths that are suitable for right triangle, where they are whole numbers mainly. So the main triad is 3, 4, 5, and based on that we can multiply all of them by a common factor, so then it will be also another Pythagorean triad. So in this case we can multiply all of those three terms by 3. I'm sorry, the value is supposed to be multiplied by 2. And then when we simplify it that way, we get a new triad as 10, 8, and 6. So just like that, we found out a sum of squares that add up to 100, so which means the 8 and 6 are the two legs of the right triangle. And here I can prove that all of these four right triangles have equal congruence concepts, because we can see the four hypotenuse are equal in all of the four triangles. Next, we can name one side's two sections as x and y, and in the same manner if we name this x, y, xy, we can see it perfectly aligns, so which means those legs are also equal to each other. Thus, giving us the conclusion that those four right triangles are congruent. So which means all of these length pairs are supposed to be 8, 6, 8, and 6. And yeah, let's put this right triangle back where it belongs, and then let's do the rest of our simplification. Okay guys, so after naming the lengths, now this problem looks a bit more simple. Now let's move on to this right triangle right here with the circle inside of it. So let me take it out. Okay guys, so now we can find the area of the circle much more easier. So I forgot to put the lengths in here, so let me just put the lengths as well. Okay guys, so just like that we named all of these three sides. Oh, sorry, these are supposed to be switched. Okay, so I switched those two as well. So now the lengths are here. Now we can just solve the area of the circle. But how? This looks literally impossible, right? But if you're familiar with tangent rules, this is a piece of cake for you guys. So now, in case you didn't notice here, you can see that all these three lines are tangent to the circle, otherwise they cannot touch each other. So because of that, we can say that these two sides are equal. These two sides are equal and these two sides are equal. Let me just demonstrate to you using algebra. First, I'm going to name this side R like this, and then I'm going to name this center to this point as R2. Now, since all the lines I drew were perpendicular to the other sides, I can name all of those angles as 90 degrees. So which means here, technically the shape I formed was a square. So these two lengths right here should be R as well. So guys, which means this total side of 6 has a part of R, and which means the remaining part of that leg of 6 should be 6 minus R. And because of the same tangent concept, I can state that the length from this tangent point to this point is also equal to 6R. Which means the remaining length of the leg of 10 should be 10 minus whole 6 minus R, where the value in the parentheses multiplies by the minus, so it finally turns into 4 plus R. Now which means the length from this tangent point to this point should be 4 plus R as well. Now here we already knew that this total length was 8. And now we have another value for 8 as 4 plus R, which in other words is 4 plus 2R. So now we can write down an equation through this length. So now guys, now I can say this plus 4 to the right side, so then it will be minus 4, so it will be 2R equals 8 minus 4, where 2R will be 4. Where at last we get the radius of the circle as 2 units. Now we can use the area finding the circle, which is pi r squared. We can substitute r as 2, so we have times 2 squared, which is pi times 4, which in other words, the area will be 4 pi square units. Where this value is approximately equal to... Okay guys, so I hope you had fun solving this math problem. Make sure to subscribe to my channel and share it with your friends. And I hope to see you guys in another video. Take care.